For this explainer, we're not just looking at history. We're opening a cold case. It's a mystery that's been buried for centuries, about a lost science, a brilliant understanding of light that ancient civilizations had, and that we, somehow, completely forgot.
So what if the story you learned in school about scientific progress, that nice, clean, straight line from superstition to modern genius, what if it's just plain wrong? What if the past was much, much brighter than we've ever been told?
Yeah, that official story is pretty neat and tidy, isn't it? A slow, steady march out of the darkness and into the light of reason. But when you actually start looking at the evidence, a totally different story starts to emerge, one that doesn't fit that simple timeline at all.
To solve any mystery, you have to start with the evidence. And let me tell you, what we have in our evidence locker today, these aren't just dusty museum pieces. Think of them as clues from an ancient intellectual crime scene, pointing to a technology that just shouldn't have existed.
First up, Exhibit A, the Lycurgus cup. It's a Roman masterpiece from the 4th century. Now, look at this. When you light it from the front, it's this kind of murky, opaque green. But, and here's where it gets wild, shine a light through it from behind, and it completely transforms, glowing this brilliant, stunning ruby red. How is that even possible?
So, yeah, how did they do that? The answer sounds like it's straight out of science fiction. They figured out how to infuse the glass with microscopic particles of gold and silver. Particles that are only 50 to 70 nanometers wide. This wasn't some happy accident. This was nanotechnology in the 4th century. The question is, how on earth did they know how to do that?
Okay, next up in the evidence locker, the Viking sunstone. For the longest time, this was considered pure myth. Something you'd only read about in the old sagas. A magical crystal that allowed Viking sailors to pinpoint the sun's exact location, even on the foggiest, most overcast days. But what if it wasn't magic at all? Now we're going to go way, way back in time with Exhibit C, the Nimrud lens. Discovered in what is now a rock, this thing is 3,000 years old. It's a small piece of polished rock crystal, and it's officially the oldest optical device we have ever found, capable of magnifying things about 3 times over.
For years, the official line was, oh, it's probably just a fancy decoration or maybe a magnifying glass for a scribe. But some researchers have a much more exciting theory. You see, ancient Assyrian astronomers wrote about the planet Saturn as a god that was surrounded by a ring of serpents. Wait a minute, how could they possibly know about Saturn's rings unless they had a telescope with this very lens as a key part?
And check this out, our final piece of physical evidence, the Visby lenses. These were found in a Viking hoard from the 11th century. What's absolutely mind-blowing about them is their shape. They have a nearly perfect aspheric surface. Now that is a really complex design that eliminates distortion, a design that people like Descartes were still working out the math for in the 1600s. And yet, here it is, perfected centuries earlier by some anonymous Viking craftsman. Our last piece of evidence isn't something you can hold. It's an idea, a 2,000-year-old puzzle. The ancient Greeks got completely stumped by a fundamental question. How do we see? Does light travel into our eyes from the world, or do our eyes shoot out some kind of invisible ray to touch the things we look at? It seems so obvious to us now, but for 2,000 years, the greatest minds on the planet just could not solve it.
All right, we've got our evidence laid out on the table. Now it's time to bring in the forensics team. We're going to use modern physics to crack these ancient codes and reveal just what these forgotten scientists actually knew.
So, that crazy color-changing cup? The secret is a principle called surface plasmon resonance. When light hits those teeny tiny metal particles, their electrons start to vibrate in a specific way. This makes them scatter green light back at you, but absorb other colors when light passes through, letting only that deep red light escape. This is cutting-edge material science, being used 1,600 years ahead of its time.
And the Viking sunstone? No magic needed. The key is a property called birefringence, which you find in certain crystals like calcite. The crystal does this cool trick where it splits a single ray of polarized skylight into 2 separate beams. All a Viking navigator had to do was rotate the stone until those 2 beams had the exact same intensity, and boom, they could find the sun with an accuracy of within 1 degree.
And this just shows you how elegant the solution was. It's not magic, it's just physics.
The distance the light splits is a simple function of the crystal's thickness and the angle. Now, the Vikings may not have written out the equation like this, but you can bet they had mastered its practical application to cross an entire ocean.
So, what about that 2,000-year-old Greek mystery, the one about how vision works? Well, that cold case was finally cracked in the 11th century. Not in Athens or Rome, but in Cairo, by an absolute genius named Ibn al-Haytham. He was the master detective who changed everything.
See, al-Haytham didn't just guess the right answer. His true genius was in how he found it. He established a revolutionary protocol for finding the truth. First, observe something in the world. Second, form a hypothesis to explain it. Third, and this is the game changer, design a controlled experiment to test it. And fourth, insist that other people can repeat your experiment to verify the results. This four-step process, that is the scientific method, the operating system for all of modern science.
And this leads us to the central question of our whole investigation. If this knowledge was so powerful, so revolutionary, nanotechnology, advanced optics, the scientific method itself, then why did it vanish? Why do we have to reinvent it all centuries later?
Well, there's no single smoking gun. It was more like a conspiracy of different factors. You had the destruction of great centers of learning, like the Library of Alexandria, erasing huge chunks of knowledge. Then, when al-Haytham's incredible work was finally translated into Latin, the translators left out the most important part, his explanation of the scientific method itself. You combine that with cultural bias and an academic culture that preferred reading old texts over doing new experiments, and the trail went cold for centuries.
So what's the verdict in the case of the lost science of light? I think it's pretty clear. The ancient world wasn't just preserving old ideas. In a lot of cases, it was pioneering brand new ones, technologies and methods that we are only just now beginning to fully appreciate.
And the connection between then and now is just stunning. On the left, that's a piece of 2,000-year-old Roman glass that, over centuries of just sitting in the soil, naturally formed something we now call photonic crystals. On the right, those are modern, man-made photonic crystals, the backbone of today's high-speed fiber optics and even stealth technology. What nature did to that Roman glass by accident, we now spend billions to replicate on purpose.
So here's the big takeaway. The so-called Dark Ages may not have been dark at all. Perhaps we were the ones in the dark, simply because we'd lost the ability to understand the sophisticated technical language our ancestors were speaking through these incredible artifacts.
And this really forces us to come up with a whole new definition of what progress means. Maybe it isn't just about inventing the next new thing. Maybe, as this quote says, it's also about the persistent, humble work of reconnecting with the brilliant, suppressed, and lost wisdom of those who saw the light before us. It's about finally understanding that others saw the light a long, long time ago, and we're just now learning how to see it too.